What we left off with, the PIDs, difference of squares, if you can find those things. So here's I am looking for stuff I know I can do. Before I write things in sine and cosine and do the fraction stuff we did before, those are all skills too. I told you PIDs and difference of squares are where it's at. You want to put on, I call it my PIDDAR. If you can locate a PID, your life will be better. Do you see a PID where I see a PID?
Yes.
Then your PIDDAR works as good as mine. Those right there make 1. Do you see that right there? These two right here, sine squared plus cosine squared, it's 1.
That equals 1?
Isn't that cool? So find those first because you love those. Everybody does. 1 plus cotangent of squared x, or I don't know why I said of, but cosangents. Yeah, can't talk. 1 plus cotangent squared cosecant x. Now, again, my PIDDAR is kind of flashing a little bit. In the back of my brain, I'm like, I think I remember all those PIDs up there having like a 1 and a trig function squared. So you hear that beep in the back of your head? I have a constant ringing in my ears, but I can still hear the beeping. Is there a PID that goes with that? And I'm not saying there always is, but sometimes, and I cannot get my, I see some, yes. Can you see it? That one. What's it equal to? Cosecant squared of x. And so, down below, we're going to rewrite that 1 plus cotangent squared. Somebody always asks, do I need to have these memorized? Not for a while, but there comes a time. I'll tell you which ones I think you should have memorized. And your PIDs will be one of them eventually. Cosecant squared. Cool. Are you guys good with where I got that from? I pulled the PID. I said this is equivalent to this, so I replaced it. And then the cosecant of x on the bottom I didn't touch. And what we see is I got a cosecant squared over a cosecant, and it's just like power rules. If I got squared on top and 1 on the bottom, they cancel to just a singular cosecant of x. That is done. That's the fun part. It's if you can learn what to train your eyes to find, then you can simplify very nicely. Your PIDDAR is just begun its work. Okay, to the next one. Fractions. I mentioned before that if you get fractions, get a common denominator and put them together. That is going to be your mantra. Those two things being subtracted are no big deal. So the common denominator that I choose, I'd say 9 times out of 10, is the product of the two given denominators. So I'm going to multiply the left side by cosine of x, and then that means you need to multiply the top by cosine of x because it's equivalent to 1. It's called, some places they call it a clever form of 1. So that left fraction gets multiplied by cosine over cosine. It's equal to 1. On the right-hand side, we are going to multiply by, let's use blue, 1 minus sine of x over 1 minus sine of x. And now, if you'll notice, the denominators will be the same. And I'll write the result in red. Ooh. So what I end up with, these two dudes, the cosine, you multiply numerator to numerator, denominator to denominator. So this is cosine squared x on top. And cosine times 1 minus sine on the bottom. On the right, I'm not simplifying yet. And I'm going to give you some warnings. Don't simplify it. Don't distribute, I should say. Hang in there. Wait. Yeah?
How are you supposed to know that you're not supposed to distribute, though?
Because I said so, Carter. That's just being sassy, sorry. I'll tell you why in a minute here. Hang in there. There's a reason why sometimes you want to be latent on your simplifying and sometimes you want to do it right away. So hang in there. Be suspenseful. That's the cool thing. Now that they have the same denominator, you know you can add them, right? So cosine of x, 1 minus sine of x. On top, cosine of x minus sine of x times 1 minus sine of x.
Isn't it cosine of x squared?
Oh, yeah, thank you. Yep. All right. Everybody groovy so far? Like getting common denominator. Once their denominator is the same, you may put them over a single denominator and simply subtract their numerators. That, I asked you to pause on distributing because there are times when distributing it in here will make this better, and sometimes leaving it undistributed will make it better. I ask you to do it cautiously because you want to wait and see. Kind of use a wait and see mentality. Get it on the page and then go, what would be better? Can anything cancel? Because in the end, it's all about canceling. We want stuff to cancel. I cannot cancel anything in its current state, which tells me I want to keep going. The process I think that we need to remind ourselves of, you may not cancel unless the glue is multiplication holding the thing on that you cancel. So if I were to write a very, very important rule to y'all, only cancel when the glue is multiplication. I cannot cancel, for instance, an example, a bad example is no, you cannot cancel those cosines because the glue holding that cosine on there is like actually a plus sign out here. But plus or minus signs, you cannot cancel things that are added or subtracted. No, don't do it. But if the glue, it's funny, I'm looking at that word cancel and it doesn't look anything like cancel. Let's try that again. Cancel when glue is multiplication. Oh my word. Ran out of room.
What does that mean?
I'll show you. You can't cancel, but it means right now, do you see that cosine squared of x that I just tried to cancel that thing? No. Because on top it's not held to the rest of the numerator by multiplication. It's held to the rest of the numerator by addition. And that means no canceling allowed. No.
Oh.
That's what
Okay,
I
I
mean.
get it.
Now, Carter's question, why not distribute, is when you get to this stage and it looks like you're stuck and I can't cancel anything, which is kind of our favorite thing to do, you distribute and see if something else appears. So he's right, we will distribute this, but I wanted you to always use caution when you distribute or simplify a little too fast. Give yourself, look at the steps, see what's going on, kind of survey the field a little bit, see what's out there. All right, cosine squared minus, now I distribute the sign to the 1, it's just sine of x. It is a minus sign, you want to remember that. And that means negative sign times negative sign, it's a positive sine squared x. That positive is going to get forgotten. One of us is going to do it, I know it. Might be me. Now, I'm putting every step in there. It'd be awesome if you all did as well, but I know many of you love to shorten the writing. Just be careful. Do you guys see anything good? I mean, as you're working along, you hear that beeping in the background?
Yeah, like the sense for us and that, like,
Yes, your PID-DAR. It's annoying. After a while, once it starts, it like beeps all the time. It's like when you get a new car, you notice all the Golf GTIs on the road now. You didn't notice them until like you engage that GTI DAR. I see them everywhere. We do the thing now where you're driving and you lift a finger. Not that finger. But you do the wave, or the nod. It's the wave and the nod to other GTI drivers, and it's like you've got a thing, you're connected.
They're part of a club.
We're part of a club.
I get this like ding in the back of my head and it goes like, and it's like when you're saying things that don't matter.
Oh!
No, just
Jeepers!
I mean, 5 years
Jeepers!
ago, trying to ride a bike out of this class.
Oh my word. Oh my word. Oh, Jacob.
It's like
Oh.
when I'm driving around my F-150 and I see another F-150. I'm like, so nice.
like
I'll get you soon. Oh, I'll get you, Batman. Don't you worry.
I'm just salty because he moved me to the back.
Yes, I did.
Emma really hates me.
What do you think? Our PIDDAR serviced us nicely. Sine squared and cosine squared. By the way, it's sine plus cosine squared. Are you okay with that one? Does anyone need a little like, this one over here is the result of putting cosine squared and sine squared that are added. They do make this one that you see right there. The minus sign that you see in the middle is the remnant. That little dude is right here. Color coding. I love color coding. Now, do you see some canceling? Can you cancel? That's the $1,000,000 question. Look at the glue holding on this 1 minus sign on the denominator, and on the top, that's also held by, it's basically 1 times 1 minus sine of x. These are cancelable.
Whoa. Does
Wait,
that work?
hold on, I'm confused.
Sure it is.
Here, cosine squared x.
Okay, let's go find it.
Oh, I got it.
It's okay, yes.
Why did that become
PIDDAR. It's all, yes, the PIDDAR.
Oh, okay.
PIDDAR, cosine squared and sine squared made 1.
Yep, got it.
But it's a training. It's like your eyes have to find a way to see it. And it's not easy. It's not always the same for everybody. Thank you, Mr. Winter. And those became 1, and then 1 minus sine and 1 minus sine because they're glued to their respective numerator and denominator by multiplication. Because I was just showing you they're isolated and they're the same. But yes, Nathan says why parentheses on the top? I don't need them, but I wanted to show that they're the same as the numerator and denominator are the same. They may be canceled now. You may cancel them. And ultimately we get 1 minus cosine, 1 over cosine of x, and that ultimately becomes secant of x. I'll write them both. And we're done. We are home free. Hallelujah. Good work. Now I'm going to give you lots and lots of fun practice. The packet, you are set for the part 1 of that packet. Enjoy it. I like that part. I think you will too. Okay? Quick time, player.
There's practice in this?